Hello and welcome to my first video in which we're going to solve the very first Leetcode problem, namely to sum. First, we will try, in my opinion, the most intuitive approach, then we will optimize it a little bit, and in the end I will show you a much faster way of solving this problem. So our task goes as follows. Given an array of integers and an integer target, return indices of two numbers such they add up to target. You may assume that each input would have exactly one solution, and you may not use the same element twice. You can return the answer in any order. Here we can see some examples. If our list of nums contains 2, 7, 11, and 15, and our target equals 9, then we can see that 2 and 7 are adding up to 9. Their position in the list are 0 and 1 respectively, so we will return a list of two numbers containing these positions. In the second example, we can see three numbers in our list, 3, 2, and 4, and our target equals 6. We can see that 2 plus 4 equals 6. Index of 2 is 1 and index of 4 is 2, so we will return the list containing 1 and 2. In the last example, we can see the list of two 3's, and they add up to 6, so we return their indices 0 and 1. We cannot return 0 and 0 or 1 and 1 because we may not use the same element twice. First approach that we will discuss is checking every possible pair of numbers to check if any of those pairs add up to target value. Here we can see the table with values of nums list and all the possible pairs. We have to find such pairs that their sum is equal to 9, which is our target. And once we find those numbers, we will return their indices in nums list. So let's try to implement this in Python. Here we can see the standard code template provided by Leetcode, and we need to finish the class method called toSum. We receive two arguments, nums, which is list of integers, and the integer target value. So first, let's iterate over all pairs of values using nested for loop. To have easy access to indices of our numbers, we will use enumerate function. Next, we want to check if two indices are different and if our numbers num1 and num2 add up to the target value. And if they do, we will return the list of indices. If after checking all the pairs we couldn't find any match, we will return the empty list. This code does its job, but due to the nested for loop, its time complexity is quadratic. We can improve this solution by noticing that we don't have to check every single pair of numbers. Since it doesn't matter in which order we will return our indices, pairs 11, 2 and 2, 11 are the same, and we just need to check one of them. Also, we may not use the same element twice, so we can reject all the elements that have the same index. In our example, it will be 2, 2, 7, 7, 11, 11, and 15 and 15. By looking only at unique combinations of the list, we are left with less than half of original pairs. To implement our improvements, we can use combinations functions from the itertools library, which creates n-length tuples in sorted order with no repeated elements. In our case, we are interested in two elements combinations, so we will pass 2 into combinations arguments. Then we will check if the sum of num1 and num2 is equal to target, and if it is, we will return our indices. If no match was found, we will return the empty list. This code should execute roughly 2 times faster than our original approach, but we can go much faster. In this approach, we can loop through the nums list just once, saving the index and element of nums in a dictionary. For each element, we can calculate the difference between target values and the current element, and we check if this difference exists in our dictionary. As we can see, we start with empty dictionary. Then we calculate the difference between first element and target value. In our case, first element is 2 and target is 9, so the difference is equal to 7. Then we check if 7 exists in our dictionary. Since it's empty, we can conclude that it doesn't. So we add 2 and its index 0 to our dictionary and go to the next item. We check the difference between 9 and 11, which equals to -2. We check if -2 exists in our dictionary and it doesn't. So we save the num 11 and its index 1 to our dictionary and move on to the next item. We calculate the difference between 9 and 15, which is -6. We look for this item in our dictionary, but we don't see it, so we add 15 and 2 to our dictionary and move on to the final element, 7. We calculate the difference between 9 and 7, which is 2. We check if we have this value in our dictionary, and it turns out that we do. So we can return the index of the current element and value for our dictionary's key 2, which is 0. We start our implementation by defining a dictionary that we will call scene. Next, we iterate over nums list. We calculate the difference between target value and current num item. We check if we have this difference in our scene dictionary, and if we do, we return the current index and index of the difference value. If we don't see difference number in our dictionary, we add num and current index to the scene dictionary. If no solution was found, we return empty list. This solution is a lot faster than the previous solution, and it's linear time complexity. But if we read the code, we may ask ourselves, why is it linear? We iterate over nums, which is already linear time, and then we check if there exists a div key in scene dictionary. In operator works differently for different objects. It uses contains special function, which implementation differs depending on the class. If our object is a list, checking for existence of an item with in operator will have linear time complexity, and if our object is a dictionary or a set, the time complexity of in operator is constant, so it depends on underlying implementation of the class. That's it for this video. Thanks for watching. I hope it was helpful to you. Please subscribe if it was, and I will see you next time.